Good morning. Nomenclature Part 2, Molecular Compounds. These are also called covalent compounds. The difference in molecular compounds and ionic compounds is that molecular compounds contain only nonmetals. Big difference, only nonmetals. No metals are present. How do you know you have a molecular compound? It only contains nonmetals. There are no ions, therefore there are no charges to balance. Instead, we use prefixes to determine the number of atoms needed in the formula or the name of the compound if the formula is given. The prefixes are as follows. Mono means 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. You will use these prefixes for the second atom always, and you will use all of them except mono for the first atom. So let me say that again. The second atom always has a prefix. The first atom will have a prefix unless there's only one of them. When naming molecular compounds, you change the ending of the last nonmetal to "-ide". The first nonmetal keeps its original name. So here's our example. CCl4. C is carbon, so we do not use mono because it is the first element. 4 chlorines, we change the chlorine to chloride, and the prefix for 4 is tetra, so carbon tetrachloride. You do not reduce the subscripts in molecular formulas. Big difference compared to ionic. Examples: S2O8, you leave it as S2O8, and it's simply named disulfur octaoxide. Most students find molecular compounds much easier than ionic because there are no charges. You know how many to write because of the prefixes. Carbon monoxide. Carbon, there is no prefix, that means there's one. Monoxide means 1O. CO, carbon monoxide. Deadly gas, no odor, no flavor, and it will kill you. Disulfur decafluoride. Disulfur, S2. Decafluoride. Deca is 10, so that's F10. Disulfur decafluoride. I will say I got those a little bit too far apart. A common mistake when people start off, so we're going to rewrite that as follows. S2, F10. Dihydrogen monoxide, that is water, H2O, but the proper name is dihydrogen monoxide. Trinitrogen, that means 3 N's. Tetroxide, O4, N3O4. Let's write formulas, or rather let's write names. SO2, how many S's? 1, so we do not use mono. Sulfur, O2, the prefix for 2 is di, dioxide. N2O5, N2 means dinitrogen. Pentaoxide, you can leave off that A since you typically don't hear it, but if you're in doubt, leave it on. Again, let's go back over this. Dinitrogen, 2 N's. Dinitrogen, O5, that means 5 oxygens. Pentaoxide. NH3, 1 nitrogen. We do not use mono, so nitrogen. 3 is tri. Hydrogen becomes hydride. Trihydride. Cl2, that's dichlorine. We do use mono for the second, monoxide. The last example we have on this page includes both ionic and molecular compounds, and you have to figure out, are they ionic or molecular before you start. Potassium sulfide. What kind of compound is that? That will be an ionic compound. You ask why. How did I know that? we're going to go back to our periodic table and look. Where is potassium on the periodic table? It's on the left side. That means it's a metal. That's how I know. So I'm going to label this one ionic. I'm going to come back and name it later. Titanium 4 bromide. Again, I'm going to go to the periodic table. Titanium is a transition metal. And folks, it has 4 on it. That's a big hint that it has a +4 charge. So of course it's going to be ionic. It is a transition metal, but that really doesn't make a difference in this example because you're writing the formula, not naming it. The name is already given. Dicarbon triphosphide. Where is carbon? On the right-hand side, it's a nonmetal, so that means this is a molecular compound. Ionic compounds balance charges. Molecular, no charges, yes, prefixes. Try to get that in your head. All right, let's go back up to potassium sulfide. Potassium is +1, sulfide's -2. That means K2S. Titanium 4 bromide, +4 for titanium 4, bromide -1. That means I'm going to need 4 bromines, so TiBr4. Dicarbon triphosphide, it's molecular. All I have to do is use subscripts. Dicarbon, C2, triphosphide, P3. All right, let's write names. What kind? N5Cl2. Where's nitrogen? It's a nonmetal. So this is a molecular. BaO. Where's Ba? It's a metal. Ionic. Fe2O3. Fe is a metal right here. And because it is in the middle of the periodic table, it's a transition metal, which means it could have more than one charge. So I'm going to put transition metal ionic. Notice every time I looked to see where it was on the periodic table, I paid no attention to the second element written in the formula. It's the first element that determines the type of compound. If a metal is written first, or ammonium or hydronium, it will be an ionic compound. Let's name it. N5 would be 5 is penta. So pentanitrogen, Cl2 dichloride. Remember, change the ending to "ide" for the second element. The first keeps its normal name. So pentanitrogen dichloride. Ionic compound, simply name what you know the ions are. BaO, that's barium oxide. Fe2O3, this is the harder out of all of these three. Why? Because you have to determine which iron is it. So in order to do that, I go to the oxide. That's a -2 charge. 3 times -2 is -6. We have 2 of these Fe's. What positive charge must that be to make a total +6? Well, we know this has to be +3 because 2 times +3 is +6. So this iron has a +3 charge. That means the name is iron 3 oxide or ferric oxide.